I'm Nick, and almost every single time when we do any of our own server stuff or all the stuff that we use here to make videos, there just seems to be a problem or some kind of really strange delay. And as you're about to find out, this video was shot a week ago because of such delays. So yeah, that's what's happened. I guess the week ago older Nick will explain what's going on. Well, no, he won't, because he doesn't know yet. And you may remember this little server here. This is a little custom 2U enclosure that I put together with some 3D printing for the front fan intake, as well as this little Intel 8 drive enclosure here that connects up with mini SAS to this motherboard here, which is an ITX board. It's from Miniroot. We did a video about this motherboard and whatnot, and I actually did a whole video about this system, but been having some strange intermittent power issues where it's just turning itself off. I thought it was the power supply that I had in here, but it turns out the wiring for the front panel button and light is doing something really weird. So instead of me trying to just troubleshoot the button, I thought, you know what, the rest of our storage servers use Silverstone cases, and Silverstone was awesome enough to send out one of the RM22-308s. This is a 2U 8-bay storage server chassis, but this one here supports full ATX motherboards. Although I won't be using any ATX board in here. I'll be using Old Faithful, the MSI D3052. It's a dual 25 gigabit motherboard with IPMI and all the fun stuff, with a Ryzen 5 7600 in eco mode. Instead of transplanting all of this, we're just going to use the drives and we're going to build something fresh in this Silverstone enclosure. Since doing the original video about this, where I designed the front panel and all of this stuff for this case, and doing the build, one of the biggest questions that I've seen is, what case was this originally? The reality is I forgot, because I purchased the original case about 10 or maybe longer, over 10 years ago, but I found what it was. I went through like old emails and stuff. This is the old Norco RPC 2304. It was a 4-bay hot swappable storage server case, but yeah, now it's an 8-bay. And to be honest, it's gonna stay in this configuration here. I'm just gonna leave all that in there because I've got another plan for this for another video. There are a couple limitations with MATX, especially in this Norco case, because it's only half depth and not full depth. It doesn't support full ATX motherboards, mainly because of the power supply location. And with a deeper case, there's just more space for full-size ATX boards. Yeah, it's still low profile, but we've got better cooling in the Silverstone case, as well as, like I said, if I wanted to just change the motherboard to an ATX board, well, let's say I wanted to be mental and put a Threadripper board in there, I could also do that. Whereas I just can't do this in something of this depth and size. So, I mean, that's the main reason. I want to be able to change it later and not restrict myself to MATX, because let's be honest, even if there was the perfect MATX board, this just doesn't have the capacity for exactly what I need it to do. As I mentioned, I'm not reusing anything except for this card with these two M.2 SSDs on it. This is for caching, and the reason why I'm using this is because it's part of the storage pool, and I don't want to have to redo the caching if I already have devices to do it. So we're just going to pull this out, use some bifurcation, and let her absolutely rip. The good thing about this card is I can add 2 more M.2 SSDs to the back of this card because it's a low profile card. This one in particular is really cheap on Amazon. It was probably maybe 20 Aussie dollars, and it does the job perfectly. I use these all of the time. I have no problem with them, and if you have a problem with them, I'm sure you'll let me know in the comments down below, right? I need to take all the drives out because they're not gonna live in here anymore. It's kind of overkill and ridiculous for this use case, but you know, the lady gets what the lady wants. And she wants SSD, so we give her SSDs.
Yeah, dude.
I do want to reuse these fans because they're quite good. These fans are very, very quiet and they've got a very low RPM. Otherwise, I just wouldn't change them because I wouldn't have a reason to, but I will try and source some more of these when I rebuild this. I'm also going to reprint all of this in PETG. I've been using PETG a lot lately, and you guys were right. It's way better than PLA. This stuff is just not good. Well, it's not that it's not good, it's just not for this use case. And I've been doing 3D printing stuff for long enough now and designing so much stuff that I'm not doing videos about. It just makes sense to use PETG. Well, old friend, you've been good, and we'll see you again in another life when you are reborn into something way, way cooler. Finally here with the Silverstone RM22-308. This is about 660 millimeters deep. So in terms of the size, it's about what you'd find for any full depth server. And I mean, the rest of the dimensions are the same because the rack units are standard. So this one, if you really wanted to know, is 88.5 millimeters tall, which is about 8.8 centimeters, as well as 43 millimeters wide. Standard measurements, nothing too exotic going on for this enclosure. There are a couple things that you'll notice that are different with this one as compared to ripping it straight out of the box. So first of all, I've installed these little rack ears on the side here. The way these work is there's a little latch and they hook into the rack themselves, so it won't accidentally slide forward off the rail if you're maintaining another server. Sometimes you'll move a server and it'll grip onto another one and pull it out. This is a much more elegant solution, and to be honest, Silverstone does this pretty well. The way these attach is there's 3 screws on each of the ears and you just attach them and Bob's your dad's brother's father. For front I/O, there's a USB 2.0 port, a USB 3.2 Gen 1 port, a power button, a reset button, a power light, a disk activity light, and 2 network activity lights. These activity lights will typically plug into your motherboard if it supports it, or some NICs also have headers for those lights too. Given that this is an 8-bay enclosure, it does have hot swap drive bays. You push the little button in, you can slide these cages out. These cages will support 3.5-inch drives as well as 2.5-inch drives. And we'll come back to the backplane in a sec, but Silverstone does have interchangeable backplanes where if you don't want to use the SAS or SATA backplane, you can use an NVMe backplane. We've shown this in the past. I'll link to another video where we built our big storage server that has an NVMe backplane in it. There are a couple other little things with storage devices in this case if you're interested. There is mounting for a slim optical drive if you wanted to do that, and 2 more 2.5-inch drive mounts if you have some type of redundant storage solution for your OS install. Otherwise, you can just use the hot swaps on the front. To be honest, thinking about this now, like after the fact, the 12-bay solution would have been maybe a bit better for the use case because I have a bunch of 36 terabyte drives that I need to use, but we're going to provision those later for something else. We'll talk about that in another video. Yeah, we've got a bunch of those massive new Seagate drives. They're ridiculous. So shout out to Seagate for sending those over. We'll get back to that in another time. Anyway, yeah, that's really it for storage and whatnot. You'll notice that the fans are missing here because even though the included hot swap fan brackets are really, really good, the included fans are relatively loud in the scale of things that I want to be making sound inside of our house. They do have a PWM connector here. However, it's not standard PWM, only in the way that it has the key. The key is really big, so you do need to use Silverstone's fans, but there is a way around it, and that is you can just bypass that when you pull these fans out and plug it straight into the backplane. As with most storage server enclosures and chassis, the backplane is actually a collection of backplanes, so this one has 2 individual backplanes. They use the SFF Mini SAS 8643 connectors. Basically, it is, I would say, an 80-87 connector split into and stacked on top of each other for space-saving purposes. And that's typically why we see it on backplanes and controllers these days, because it just makes a bit more sense because they are a bit more compact. Forever Molex, unfortunately, but that's the way the cookie crumbles in servers and enterprise. It will forever be Molex, and it will always be Molex forever, until it's not, until they decide to use PCIe power or EPS power, which we do see on some server enclosures, but Silverstone uses these backplanes with Molex, which is fine, as long as they don't catch fire like that one time where it did catch fire, but that was my fault. And kind of hilarious at the same time. Every time I do these builds, I find myself buying new cables where I could have just pulled them out of another system, or I already had spares. So let's not tell Claire that I bought another set of cables that I didn't need. Oh yeah. Well, these are SFF 8643 to 8087 cables, pretty standard. The reason why I'm using these and not straight through 8643s is the HBA that I'm using is an older one, but it is a good one. This is an old LSI 92-308i that I've had laying around for a little while. This is a fairly reliable HBA. It is a bit old, it's getting a bit long in the tooth now, but this one, as you can tell, I've modified. This has a little fan bracket that I've 3D printed. I based it on another model, but I think that this fan grill looks way better. I also modified it to have those plastic push pins for the fans rather than screws. And I printed this out of PETG, so it's better than PLA and probably won't warp. And actually it won't warp because I've used PETG many times on things that I don't film on the channel, and they've stood the test of time very, very well in these server enclosures. Well, my friends, here is my favorite part of every single server build. Wait, no click today? Fair enough. Let's see if the other one gives us a click. No click today, come on. All right, the bit you've been waiting for, the hardware. Well, guys, I've used this motherboard a bunch of times because the reality is I have two of these motherboards. This is the MSI 3052. This is an MATX AM5 motherboard that supports Ryzen 7000, 8000, 9000, EPYC 4004 and 4005 CPUs. Because I want this to be cool and quiet, I've decided to use a CPU that has stood the test of time with these type of builds, the AMD Ryzen 5 7600, the non-X version. That's because it's a 65 watt part. It uses pretty much no power at all. And you can put it in eco mode and we can make this sip about 35 watts, so it won't get very hot. It's got 32 gigs of RAM, basically because you guys know what RAM is doing these days. And yeah, that's the reality and the nature of the beast. It's expensive. I did have 64 gigs in the previous configuration, but we just don't really need it with this setup. It's not ECC memory as well because it's almost impossible to get at the moment because of the naughty A and the I. As for the OS, it installs on this little guy here. I've talked at length about SATA DOMs or SATA disk on modules, and essentially the way it works is it plugs into a SATA port on your motherboard, then it has power coming from your motherboard to power the SATA device. This is a 64 gig InnoDisk module that I pulled out of an HP server 10 years ago when 64 gigs was heaps of storage for a hypervisor. This one had to be modified like the one in our other storage server. I had to change the polarity to work with the power on this board, as well as clipping off a tiny part of the connector to fit on the MSI board, but it does work. And these are relatively cheap to pick up online and great for home labs and servers if you don't want to have to physically have another drive powered, or if you want to save some PCIe lanes if you're using NVMe storage, or just don't want to use an M.2 slot or a drive bay. They're great. They're really, really great. And most operating systems for these use cases will be less than 64 gigs. Even an 8 gig one would be fine for most OSs you're going to be running on these. And finally, the cooler. This is an interesting one. The cooler is the Scythe Shuriken 3, I think. Yeah, that's what it is. and I've whacked this 92mm Noctua fan on top just for, why not? Why not? Why wouldn't I do that, right? And I can, so I did. Well, friends, everything was going to plan until I realized that the SAS cables that I bought, I kind of had a feeling that this was going to be the case. So I have a solution to the 3D printer. Also going to need a riser cable, but to the 3D printer. You guys saw that the cables weren't long enough for the HBA, and I chat about this a little bit later, that I could have just ordered longer cables, but the lead time for those cables to arrive would have been actually longer than what I mentioned in the video, being a week. It was going to be closer to 2 weeks. I just don't have 2 weeks to allow a whole server to be offline for, so we had to improvise. I did design these brackets, but while the solution prints, I guess we should talk about how we're going to power the system. This case will only accept 2U power supplies, which is a server form factor, either 2U redundant or 2U single power supplies. This is the new Silverstone 2U850 RX Gold. It's an 850 watt, 80 plus gold rated 2U single power supply. This is pretty excellent that this is widely available and it's not a niche power supply. So, you know what? Look, I know Silverstone sent us a whole bunch of stuff for this system, but the fact that this power supply, again, is really easy to get and it's 850 watts for a server like this. I don't know why I find that so exciting, because 2U power supplies have been pretty difficult to get in the past, so yeah. The width of the profile of this power supply is smaller than SFX, but it's much longer than SFX. Essentially, you just want to load it into the back like that, and then away you go. I did design a bracket to move the HBA with a riser cable, but as you're about to find out, again, strange things happened. You know how they say things don't go to plan? Well, that's kind of what happened here. It's the next day, and I finally have a bracket to move the HBA. I designed it a couple different ways, and I printed it a bunch of times, kind of tweaked a few things to get the perfect version of this done. And I finished at midnight last night. When I say that I finished designing at midnight, rather what happened was I hadn't even printed another version of it at that time that would work, because I redesigned it the next morning after filming all of that. These are the prototypes that I ended up like designing, different configurations of the way of mounting the HBA in the case, different offsets, different like motherboard screw patterns, a whole bunch of different stuff, until I arrived at the one that you're about to see right now. And it's the one that is currently in the server. I hope to finish this whole video filming wise in one day, but it didn't work out. So let me show you how this bracket works. You'll see these motherboard standoffs here for a regular ATX board, and we're going to use those. Essentially, the way this works is this bracket uses the hole spacing for that and then screws into those. When editing this part of the video, I'd realized that I didn't properly explain how this works. I kind of did, but this will make way more sense. So essentially the way this works is it mounts to the motherboard tray via these two screw holes here. These are the same size as regular motherboard screws, and these little bits here, they go over the top of the standoffs on the motherboard. So you can see that it has a bit of a cutout or indentation for that. Now, the next part is, you'll notice there's two more holes here. These are for embedding brass inserts into, and essentially what this is this is where the riser cable screws into these two sections here, making it a bit easier for the riser cable not to move around. And then we have this here. This is a little bracket that goes on top, and the screw goes all the way through to mount the riser cable to it. And then there's another hole at the top which has another brass insert which you can fasten the card to, so the card doesn't pop out of the slot. Now, I hope that makes a little bit more sense to you guys. And I know I kind of talk about it in the next bit, but showing you guys the 3D model is probably a little bit better than kind of showing you this thing that doesn't really make sense. Oh, before I forget, this little tab here, this goes under the motherboard with a little isolation pad that I put on it so it doesn't lift up. But essentially, like, what happens is if there's too much force on the mounting, because there's only 2 holes mounting it, it'll start to do this, and we don't want it to do this. And the motherboard is more than capable of holding it down. The way to install this is you kind of put it on an angle so it slides under the motherboard, and then it lines up with those standoffs, whiz up the screws so then they go into the standoffs. And now we get our riser cable. This won't work for every riser cable, mind you, because this one is specifically designed for this riser cable. This little bracket here, which is a support bracket for the card itself so it doesn't get pulled out. Very hard to do this while filming because it's very easy to do it otherwise. All right. Like that. Hopefully you can kind of get an idea of how this works. I'll show it in a second. And then we screw the front one in. Whiz it down all the way. This bracket is designed with spacing to pull the riser cable back in a nice tidy way. So you kind of run it like that. We then slot the card in, like so. Then we get this screw with another nylon washer that goes into one of the standard mounting holes that go through the card anyway. This just prevents the card from being pulled out of the slot at any time. That's held in. And then we just plug the riser cable in and it's got a perfect bend. Ultimately, this is not a terrible solution and it does work. I have tested it. That's the only reason why we're at this part of the video. And look, it doesn't come unplugged. It sits in there nicely. It's really snug and it's not gonna move around at all. If you're wondering why I didn't remove the low profile bracket, well, I don't want to lose it just in case I change the configuration. And it's just nice to have it so I don't have to put it in a pile of other brackets that I've got and wonder what it's from. Yeah, okay, right. Let's see if we get a good sound happening today. Ooh, yes. Ooh, very nice. Now, while you could argue that, hey, why don't you just get some longer cables? I couldn't get any cables in a timely fashion that were long enough. Basically, I would have needed them to arrive today and they would have arrived in a week's time. So we're not doing that because this storage server has been offline for way too long. Let's see if it works. I was gonna do the thing where I press the power button for the first time, but this motherboard already was configured to resume and power itself back on once power has been restored. And yeah, look, it just posted on its own. You could just hear it beeping. It is working. I already went through the BIOS because it decided to power itself up. But now I need to get the OS installed and then restore the backup so then we can let it rip and let it do its thing. Typically when I'm installing an operating system on a new server and restoring a backup of a configuration for a new install, which essentially makes it the old install, I'll disconnect the SAS cables from the HBA just to ensure that when I'm installing the operating system, I don't make any mistakes. And sure, like you could just leave it plugged in and just make sure that way, but this leaves out any room for errors. As well as that, it also means that nothing is intentionally or unintentionally going to be written to the disks as I'm installing an operating system, because stranger things have happened. So I need to get the operating system up and running on here, restore the backup. We use TrueNAS Community Edition on all of our storage servers because that's what works, and we've been using that for years. And yeah, we'll just get it back how it was, I suppose, and we'll rack it up and call it a day. Install. We want to install to this 64 gig SATA DOM and let it rip. Proceed with installation. Of course we will. Alrighty, we finally have it booting. So we're in, it's up and running. I don't have any disks connected yet except the 2 cache disks. We'll go to System, we'll go General Settings, Manage Configuration, upload file, and that is the file there. We'll hit upload and we'll let it do its thing. It's about 3 days later after restoring the backup. You can see that everything came up just fine. There were no problems whatsoever. The storage pools are here, and there's not really much to report more on restoring this, but there are a couple other things that I want to chat to you guys about when it comes to this system, because as usual around here, when we do home lab stuff and servers, it just never quite goes to plan. The final twist for this video is kind of an unexpected one. Silverstone had sent across the rack rails for the enclosure, and they accidentally sent the wrong one. So when I went to go and film racking the server up, I didn't have the right rails. Luckily, I placed it on top of our current big storage server, which this one was sitting on top of, which is exactly 2U. So I just slid it into place for now while I wait for the new rack rails to arrive. I didn't want to delay this video anymore because it feels like it's been an eternity since I started shooting this video. And to be honest, when these kind of things happen, I'm really excited when we start off, but then I get kind of not frustrated. It's kind of annoying that, like, if one thing goes wrong with shooting these videos, it just seems to be everything going wrong. Like, nothing was catastrophic, don't get me wrong. It's like not the end of the world, but you just get frustrated, like, oh, this thing's not working. And the reality of this is what happens to people every single day when they're building PCs. I see lots of comments of people buying things and stuff not working, and stuff like this happening to me makes me realize that even if you know everything about everything when it comes to PCs and servers and whatnot, there's a lot of things that are still going to be out of your control. And my friends, that is life in a nutshell. We don't have a crystal ball and we can never ever tell the future. But hang on, if you're still at this part of the video, why is this Norco case that I did the 3D front for still on the table? Well, here's a little sneak preview at what I've decided to do with this enclosure. This is a mock-up, well, not a mock-up, this is really what I'm working on at the moment, where I'm going to remove one of the fan mounts on the front, as you can see in the 3D design here, and create a slot in for a jet KVM to sit on the front. So it'll have its little touch screen on the front for remote management, meaning you don't have to have a motherboard with IPMI in this enclosure because the jet KVM will be integrated into the chassis, which I think is just a cool idea. And maybe someone's going to steal my idea by the time this video comes out after me, like, doing this, because I haven't seen anyone really do this. And if they have, I didn't copy you. I'm just not aware of whatever you've done. Anyway, I'm going to shut up and get back to some 3D printing.